Right. So right now I'm going to explain how the cryptogen tool is actually used for the fabric. Now this is our network structure. We can see that we have one organization 1 and organization 2, and organization 1 has 2 pairs and organization 2 also has 2 pairs, and there is the orderer. Now what we are going to do, I mean how the communication process actually works, then we have to see this picture, that we as a client, our client wants to communicate with the network, and here is the peers, and we want to establish communication from our client computer to a peer computer. Now we need the SDKs that using this thing they format this our instructions and they transfer to the peers, and from peers to our client. Now to establish this communication we need some kind of identity, and for to provide this identity we need a certification authority in normal life. In real life, in a in real life we have a public infrastructure to provide this facilities, but the thing is that here we are running a simulator, and so we do not have this thing. So instead of that thing we will automatically generate our cryptographic materials which will be used for identity management. Now here we can see that in this case, for example, in this diagram we have the certification authority, and we have these elements. We have the users, user 1, user 2, user 3, and here is the orderer, and here is the peer node. Now we want to create or revoke the identities of these entities, or now we can see that here card certification authorities provided the necessary certificates so that everyone now can trust each other and can establish the communication. Now back to the cryptogen tool. Now what is cryptogen tool? Now cryptogen tool will be used to produce cryptographic materials like certificates, private key, public key, this type of thing. Now to start this process we need to set up, we need some configuration, we need to configure these things, and then it will generate. For example, suppose we have 2 pairs, and so we need 2 certificates and 2 private keys, this type of thing. Suppose we have 5 pairs, then we have 5 organizations, and each organization has 2 pairs or 3 pairs. Now these are all the configurations, and all these configurations are written inside a file. And what's the name of the file? The name of the file is cryptoconfig.yml. Now this is running inside a Docker container, and for that reason the format is YAML format. It's written the configuration. The total configuration is written in YAML format, so that it will the Docker will understand and it will start processing. That is fine. Now we can open the file and can see that what's inside this file. Now we can say that okay, now this is the orderer. Here we can say this is our orderer, this is our peer. Now we have one orderer in our current network configuration, so we have this thing, name, domain. Now the host name is orderer. Now it's the local host IP address is 127.0.0.1, right? And sans, the word sans means alternate name system, and some alternate name system probably. Now this is the peer. Now we can say that we can define that how many organization we have. We have organization 1, and now we have organization 1, and this is our organization 2. Actually this is it should be organization, not org, because this is generalized form, so it's org. Now this is our own organization and this is our another organization. Now this is the domain name of the organization, org1.example.com. And how many nodes we are defining? We are defining 2 nodes. We can change it to 3, we can define the 5, we can change it to 10, then it will define this way. For right now, let's go back to the default value 2. Now similarly, organization 2, we have two pairs. So, and how many users we have? For this pair we are defining one user, and for organization 2, single pair, I mean not double pair, and for these 2 pairs we have one user. So we define this thing, and that's it, that's the file. Now this file will be used as an input to the cryptogen tool. This is our cryptogen tool. Now where is the cryptogen tool actually? Now cryptogen tool is actually defined here. I mean, if we check it here, here is the bin folder. These are the tools, and this is the cryptogen tool. Here, this is our cryptogen tool. Now this tool will execute. Now this tool, to execute, for executing this tool we need some input, which will explain the settings, how we want to produce our output. Now when we done this thing, the output will generate. Now when we are doing the thing, we have to configure this way. This is our ---- config and then we have to mention that where is actually our YML file is there. Generally it's on the same directory, so but we have to mention that okay, this is our YML file. For example, we have to mention that okay, this is our YML file, like this. Okay, this is the image, so I cannot edit it, but here I can have to copy it and paste it here. And then we have to provide our output, because it will generate our certificates, our private key on folder. Now we have to do ---- output, and in that folder the file will be generated. Now we can start our process right now. Then go back to our areas, channel artifacts. Okay, so it's empty, but next phase we will generate more items. Now the channel, inside the channel we have the cryptoconfig YML file, and we will create a file cryptoconfig. The file we will generate. Now where actually it is generating, we are generating this in the same directory, and we will execute this shell file, cryptoconfig create artifacts dot shell, because we want to create some artifacts, cryptographic artifacts. Now right now actually we do not have a file, so we do not need to remove anything. So I just pause this line, pause it. Now we want to execute only this line. Right now we only wants to execute this line. We only wants to execute this line. Now we can say that here we want to explain that this is our YML file that will be acts as the input, and our output will be generated and it will be stored in a folder. We will create a folder, cryptoconfig folder, and inside the folder all the cryptographic artifacts will be stored. So let's go and execute it. Now let me clear this thing. Now here we can see that this is our shell file, and we want to execute that file. So okay, yeah, so I need to close this file, save it, and here as soon as I execute this command, we will see that there will be a folder name crypto the name of the folder will be crypto config. Okay, then execute it. Here we can see that immediately crypto config folder is created, and inside this folder we can see that there are two separate folders, because one is the orderer. In a generalized sense, we have created orderer resources cryptographic materials for cryptographic materials for the peer. So first let's visit the peer organization first. Here we can see that we have organization 1 and organization 2, right? And in the organization 1 we have these folders. These are all folders of this common. I mean, for example, CA, certification authority, and inside the certification authority you can see that we have the certificates, and this is the private key. And MSP, membership service provider, this will be used for checking the identity. Here also see that some other elements are there. And peers, inside the peers we have created two peers, so we should have found that two separate folders, but this is the TLS, transport layer security certificates, and this is the folder for the user. Here we can see that we have two users, one is the admin, another is the normal user. Now the inside the peers we can now visit there, and here we can see that we have two subfolders, MSP and the TLS, and again in this inside MSP and the TLS, and inside the MSP these are all the elements are there. Now let's us visit the orderer. Now inside the orderer we have this domain name example.com, and here we can see that the CA, MSP, TLS, CA certificate and the users, it are all common. And inside the user, here we can see that only admin is there, no general user, because the orderer can only be accessed by the admin, so no normal user can access this folder or the orderer node. Now in the orderer we can create multiple orders, but right now I have simplified this thing, so we have only single orderer. So we have the MSP and the TLS, and yeah, now we can say that actually what is created inside this diagram, that these are all the common elements. Certification authority, and a peer organization also has the certification authority. MSP, member service provider, and the TLSCA transport layer certification authority, and the users, it are all same. And again organization 2 similar thing will happen, but here the new thing, only unique thing is that orderer, and here the unique thing is the peer. And inside the orderer, because as there is only one orderer, so we have the single folder MSP and the TLS. In this case peers, okay, we know that we have multiple peers, but if it is now each peer has the MSP and the TLS subfolder. So now we can see the same view using the here we can see that these sort of things happen. So we can enter here, and I can visit inside the crypto config folder. Okay, and now these are all the subfolders. We can see that the order organization and the peer organization, but we can also very easily see that how it's actually subdivided. Here we can see that the tree structure is found. For example, we can see that here is the main division, orderer organization, and the peer organization. And inside the peer organization, let us visit first the peer organization. We can see that this is the domain name of the peer, and we have the certification authority, we have the certificate, we have the private key. Inside the MSP we have the admin certificate and the certification authority certificate, we have the config YML file and the TLS certificate, and inside the TLS certificate, and then the peers, but later I will visit later. Now this is the TLS certificate, we have the private key, we have the certificate, we have the user, two types of user, one is the admin, another is the normal user. normal user, and both have the MSP and the TLS. It also has the MSP and the TLS. Okay.